Hi everyone! In this video, we will use the empirical rule. Suppose a random sample of test scores from a large population of students has the given sample mean of 79.5 and sample standard deviation of 6.2. Assuming the scores are approximately normally distributed, between what two scores would you expect approximately 95% of the data to fall? Let's go ahead and draw what it would be to be normally distributed. Normally distributed follows a beautiful bell curve, and our data was told to follow it approximately. So we're going to draw a nice beautiful bell curve. And now let's go ahead and label it. We know the very center of the bell curve for a normally distributed data set is the mean, or mu, and normally distributed data contains most of the data within 3 standard deviations of the mean on either side. So I'm going to give ourselves a couple of evenly distributed standard deviations. So now we have one standard deviation above, another standard deviation above, so that's 2 standard deviations above, and one more standard deviation above is 3 standard deviations above. And going to the left, these are below, so it's 1 standard deviation below, so it's subtracted. Another standard deviation below is 2 total from the mean, and one more standard deviation below is a total of 3 standard deviations below the mean. And now we can go ahead and fill in what we have to match the approximate standard deviation. We were told that we have a sample mean of 79.5. So we can put that right in the middle of 79.5 for the score. If we add the standard deviation, the sample standard deviation is 6.2, and add it one time, we will get 1 standard deviation above, making the score for our first standard deviation above, adding that in, is 85.7. If we add another standard deviation, we will end up with, add 6.2 to the 85.7, 91.9, and adding another 6.2 gives us 98.1. And this was adding 1 standard deviation of 6.2, which we were given at the beginning. And we add another 6.2. Going to the left, we're going below it, so we will be subtracting 6.2, the standard deviation, giving us the first standard deviation score below is 73.3. Subtracting another 6.2 gives us the score of 67.1 for 2 standard deviations below the mean. And one more standard deviation below, subtracting 6.2 gives us 60.9. And now we have all of our scores that correlate to our approximately normally distributed data. And we were asked that if we assume that they're approximately normally distributed, between what 2 scores would we expect 95% of the data? 95% of the data to fall. And because normally distributed data follows a very similar trend, this gives us a rule of thumb, or the empirical rule. This means between 1 standard deviation of the mean, all of the data that falls in between these 2 scores is approximately 68%. Within 2 standard deviations of the mean, approximately 95% of the data will fall, and between 3 standard deviations of the mean, we'll approximately have 99.7% of the data if it's normally distributed. So in this case, we are looking for 95% of the data approximately with this, and it will fall between 2 standard deviations of the mean. That means between here and here, all of this data is approximately 95% of the data. And then we can go find the scores that give us those 2. So we have the score that correlates to 2 standard deviations below, which is 67.1, and 2 standard deviations above, which is 91.9. So we know our 2 scores between which 95% of the data will fall, which is 67.1 and 91.9. And we're all done.